any of the other sections. It's kind of like a miscellaneous, but this is a really interesting section. Actually, funny enough, one of the most interesting is the very last one, last menu, last line. Right, it had to be slave damper override. If I click this and I were to put 100%, all my zone dampers will open all the way. If I put 50%, they would all open halfway. So this is particularly useful for the balancing guy. Actually, just about 2-3 weeks ago, we actually had a balancing guy come over to our office and asked us, how does this work? So we had the balancing guy learning how to use the focus. So he could come in, because he said, I've got a lot of my clients are starting to use it more and more, and now I have to learn how to do this. So he just came, took us like 10, well, maybe 20 minutes, you know, showing him how it works, and he was a happy camper. So he could go onto any of those jobs, balance it on his own.
And again, no software, no special tools.
Well, with software.
Yeah,
free software.
Free software.
Free software. Yeah.
If it's a balancer,
there's a
cost.
cost.
So.
Yeah.
All right. Take that off.
Okay.
All right. Outside temperature overrides. Here we see output 3, 4, 5. Who are we talking about here? Output 3 or 4, 5 applies to the zones only. Okay. Like for example, with the light card, which I was talking about, which only has 2 outputs, well, we call them output 4 and 5. Okay. And basically, the full card with 5 is output 1, 2, 3, 5. So what we can do is, suppose now I'll say if temperature is greater than, I don't know, we'll put 70, and I know that all my baseboards are on output 4. You click on that, you're basically disabling all your baseboards if outside temperature goes higher than whatever. Likewise, you can flip it the other way as well. If it's less than -4, and you know, I don't know, all your duct heaters or all your baseboards or whatever you'd like, you can say, I want to put them at a minimum of 25, because I know it's pretty cold outside, so I want to make sure those baseboards are on at least at a minimum. Okay. And this magic little button down here, set participation, you can choose which zones this rule applies to. This just
So you could set up all the peripheral zones to follow these functions, not necessarily inside zones.
Yep.
Do you have to set both, or you just set, like if you want
Oh.
to be enabled at 30 degrees, you can just do that?
Oh yeah.
Okay.
So see, like if I just put it like this and I don't click anything, well then it doesn't apply to anybody. So you can choose whoever it applies to. We have a morning warm-up sequence, which once again, these output 3, 4, 5 is we're talking about the slaves, and so basically we'll say, okay, supposing we know everybody comes in at 8, so we'll make the system turn on at 7, and we'll put let's say I've got all my baseboards, I'll say for 60 minutes. So you're basically going to say, okay, my machine is going to turn on, all my zones are going to turn on at 7 o'clock, but I'm going to disable all my outputs for at least an hour. So that way it's your rooftop unit, which is trying to heat up your system, and not your baseboards as well. So once again, trying to save on energy as much as possible. All right. Okay. Sometimes when you guys receive an M1000, it's got a wacky time and year. Like sometimes we're in the year 2067, and it's like 3 in the morning. But so just click on Edit. So it looks at your computer time, and here's the device time. See, actually, I'm kind of off right now. I'm off by 3 or 4 minutes. So I can just do copy, and then he automatically copies himself. And we also have a daylight savings time feature. So you just choose when it comes into effect and when it turns off. So yeah. Okay. Okay. So that's just a basic view. Now I'm just going to tell you guys a bit. Okay. like how does it work? I mean, in terms of, okay, I've got my zones. Each zone has either a heating demand or a cooling demand. So first I'll tell you guys how do we calculate this demand, just quite simply. And then how does the rooftop take into these, how does it take these into account? If we go back here, we'll go on to temperature. Remember we were talking about PI control loops? Well, here's where it all happens. Basically, the entire system works off the demands from the zones. So if you're able to master, you know, your knowledge of the demands, then you will not have a problem. So it's basically all about the proportional part. If I put my mouse here, we have a little pop-up that comes up. Okay, so here we have a heating set point and a cooling set point. Where in between those two, you're fine, no demand. So basically, as soon as you start deviating from your, let's say, from your heating set point, your heating demand is slowly going to start building. So it's a percentage, which is slowly going to go up. Now, on top, you see it says proportional divided by 2. So what do? We take that proportional value, which is 5.4, and we divide it by 2. And we basically put the 2 halves on each side of the set points. So as soon as you start deviating, your demand will slowly go up. And once you've deviated by 2.7 degrees, your demand will be at 100%. And anywhere in between that, it'll be proportional. So if you're, you know, at halfway of the 2.7, will be 50%. So that's basically how each zone will create a demand. So okay, so now I've got all my zones are making demands. Now how does my rooftop unit process all these things? Just double click. Okay, well here's where the math functions. People usually get a bit scared when they see math. It's okay, I get scared all the time. But just click on math. Okay. I'll show you guys how we do it, but we have different functions. So what we do, we'll say math 1. We're going to take the weighted average of the cooling only. So that means all the zones which have a cooling call, we're going to take all those calls, put it on one side, and make an average. Math 2, you do the same with all the heating. Take all the heating calls, make an average on the other side. So now I have a general demand for cooling and a general demand for heating. So what do? If I go into my cooling, it'll say, what's my cooling demand source? So where am I getting my demand? Well, math 1. My heating, if I double click, where am I getting my heating demand source? From math 2. So now basically we have these percentages. Now suppose we have an equal demand both, right? It happens sometimes. Got 50% demand cooling and 50% demand heating. Who wins? Go into config, priority. Here we go. So it can be automatic. You can say if it's colder than this temperature, heating wins. If it's hotter than that, cooling wins. Or depending on the application, you can do it manually. Say I always want to be cool, no matter what. Cooling always wins. So that's basically how our rooftops basically are able to manage heating and cooling. Now, if I go back into these math, so this is what we chose for that. But we also have maximum heating. So it doesn't have to be an average. It can be whoever has the highest demand wins, period. So maximum heating, maximum cooling. We also have an occupancy and override, which is a few other things. Okay. All right.
Group weights.
Oh, yes. Thank you, Brian. Each zone obviously creates a demand. So he's got a vote, right? He's voting. So each vote has a weight to it. So you can, if I go into network, the group codes, basically just look at the bottom one, just the global group. Everybody's part of the global group by default. And as you can see, he's got a weight of 1. So by default, everybody has a weight of 1. So everybody's equal. Suppose you have, you know, the owner's office, which is, you know, a lot more important.